are space weather events and cosmic rays which impact nanosatellites much more than big satellites. In fact, nanosatellites are very small, and that's why they are very vulnerable to space weather events and cosmic rays. This is our group participants, only 5 people, but the working of the group was very productive. We outlined the main problems of nanosatellites and also the ways of their mitigation. So the first is space weather production of electric discharges and short circuits inside satellites. And the mitigation measures which we suggest for this is switching off the electric systems of the satellite. Mainly of the satellite computer, because short circuits may happen in satellites only if there are working electric circuits. And in fact, the mechanism of this is that space weather particles are protons which are positively charged, and they charge the shell of the satellite, and then electric discharges may happen inside the body of the nanosatellite. And also we propose development of dedicated sensors and special logic circuit for this purpose. And still there are problems with these measures, and the main problem is how to awake the electric systems of the satellite after the end of the space weather event. Second problem is space weather production of inductive electric currents in the satellite shells. In fact, space weather particles carry frozen magnetic fields inside the space plasma. And these magnetic fields produce inductive electric currents on the shell of the satellite, and in fact there are no measurements of these currents. But for example, this process produces currents inside the geomagnetic shell of the Earth, which are from 1 to 100 million amperes. So such kind of currents may be very significant. Of course, it depends on the size of the body. And mitigation measures are to use highly conductive material for satellite shells, which is able to hold high currents. The third type of problems is space weather production of communication interferences, and mitigation measures which we suggested are using of frequencies which are less effective to interferences from space weather. And the second group of problems is cosmic rays impact on space missions. Galactic cosmic rays produce a combination with the electric conductivity centers in semiconductors and are turning them into electric isolators with the time. In fact, what happens inside the semiconductor, in order to have any conductivity, you need to have 3 electrons. And protons from cosmic rays tend to recombine with these electrons and are turning them into hydrogen atoms, and semiconductor became complete isolator, and electrical system of the satellite stopped to operate. Mitigation measures in this case, which was suggested by our our colleague Jürgen from South Africa is to increase the size of the semiconductors. So in this case, they will live longer. The second problem is with solar cosmic rays. Solar cosmic rays are produced by solar proton events, and solar proton events can be predicted by looking at the solar surface in X-rays. The same kind of prediction is used for space weather prediction. That's why the mitigation measures for solar cosmic rays are the same as for space weather. And the third problem is galactic cosmic rays in result of communication produce loss of communication. And in fact, cosmic rays are going to become very big issue when we are going to send nanosats to the moon. Something what our colleagues from Surrey technology intend to do. Because the moon doesn't have any geomagnetic shell, so any nanosatellite on the lunar orbit will be affected very hardly by the cosmic rays. And in the end, we believe that the measures which we suggest use in nanosats may increase the lifetime of the nanosat several times, and their lifetime may become as long as of the big satellite. So we believe that work of our group was very productive, and the possibility to bring together engineers and space scientists was more than excellent, and we would like to thank to the organizers for this great idea and for this possibility to have this chance. Thank you.
Standardization approaches of efficient electrics are in Sophieski for